we had a question about like, what does it take to move from my graphics engine to Hoops Visualize? And so, James, why don't you talk us through that experience?
No, yeah, that was a great question. So, and it kind of touches on this exact topic. So, what I want to talk about today is migrating from a previous engine into Hoops Visualize. Um, and so, just really briefly, some background on Thermoanalytics, the company I work for. You have about 70 employees, 20 of them are developers. So it's a kind of a small company, obviously. We mainly focus on developing software that simulates thermal phenomena. So how hot something is going to get, how to cool things like that. Therm is the name of our main software product, so you might see that name throughout this presentation. So some background on the product that we create. So it's a 3D thermal simulation software. It has certain extensions for modeling humans and batteries and exhaust systems. But the main focus is to generate fast, high quality results with a very intuitive UI. Specifically for the graphics system, the 3D visualization is using shell geometry. So rendering elements, rendering faces, and then those colors can change per vertex. So there's a lot of data management going on there. As far as the development team goes, we're a small team of developers and testers, and we had a small team dedicated to this migration. Previously, we were using a homegrown OpenGL 2.0 engine, which historically had been migrated about 10 years ago from OpenGL 1.4, and then that was even predated by GL back 25 years ago in the old SGI days. So there's been a lot of migrations going on in this product. And so we were running into model size and speed limitations, having to port this old code, and then testing on the hardware and the different drivers was difficult for a small team. So really quickly, I want to do a demo of our main product. So this is Therm. So it's mainly dominated by the 3D graphics window, but it's integrated obviously into the rest of the application. And so one thing that we did add is we have the ability to switch between the new advanced Hoops engine and the old OpenGL legacy engine. And so at any time, the user can switch between these two engines. And we'll see why that was helpful throughout this presentation. And so because of that, anything that you can do in one engine, you should be able to do in the other. And so we have animation transitions where you can animate and look at different parts of the model. You could also we also have a cutting section that we can turn on, and so this can be used in the Hoops engine, but also this was an existing feature in our legacy engine. It just looks slightly different, but it's more performant than the Hoops engine. And so this kind of gives some background as to what the product's doing. So I'll switch back to the presentation. So the main focus today is I wanted to give some insights into what we learned migrating our engine to use Hoops, specifically the HPS APIs. So firstly, we needed to refactor existing features. We needed to prioritize features because this was going to be a multi-release schedule. So we need to work on those high priority features. Dual engine support, where the user can dynamically switch engines that they want to use. We had a lot of automated testing to make sure that what the user is doing it is predictable, so we can make changes if we want without having to worry about breaking existing functionality. and some low-level rendering stuff around shell coloring and how we were able to use that, as well as some custom rendering effects that we were using. So specifically with refactoring, before we even started the project, we had this idea to refactor the code with the eye toward the future. So before we integrated any Hoops Visualize code, we needed to identify and isolate that legacy code so that we could identify which pieces are going to get displaced by the new Hoops APIs. And it also forced us to look into how we were managing our application and how we were managing that graphical state. So by refactoring that, we can get a more granular sense of changes so that we can really take advantage of Hoops and how it's organized and how it operates, along with the notification system, so that we're not just changing data unnecessarily. By controlling that, we can get the performance that we needed to. So the main thing is we use graphics abstractions throughout the entire application, so that as we migrated to Hoops, we can identify which pieces needed to be that displaced our legacy functionality. So the next one is, the insight we had was around feature prioritization. And so here we needed to balance bringing over existing features versus introducing new capabilities. And so it's always nice to have these flashy new features that it gives us, but because we're bringing in this legacy stuff, we had to do, we couldn't change the experience for the user because they were used to the product behaving in a certain way. And so that focused us on these high priority features that were core to the experience of the application. And then there was a large group of medium priority features that may be seldomly used, but they are still important to our users. And so this allowed us to have this fallback where the user could always fall back to the previous engine. And then throughout this process, there were a few features that had just been sitting there for years that really nobody was using, that we identified that could be deprecated. And so the next insight is around this dual engine support, where one of the requirements was we couldn't break or disable the old engine. And so we knew that this migration would take time and it would span multiple releases. And so it forced us to identify these high priority features and identify these abstractions so that the application could interact with the graphics in a more generic and abstract way. And the main benefits for our customers has been to, they can preview the performance and capabilities, almost from day one, knowing that it's not feature complete, but at least it gives them a sense of the model sizes that they can use, the performance benefits and things like that. And for us, being able to test with the old engine for testing was critical, so that we knew that we weren't breaking something and we knew what features we needed to bring over into Hoops. The next big thing was around automated testing. And so using some kind of automated GUI testing tool was critical to us for acute applications. So we are using Squish, developed by FrogLogic. And so this allows interactions to be recorded and then played back. And it has support for Linux and Windows. And so what this allowed us to do was record certain events using the legacy engine. And then if we do those same actions again with the Hoops engine, we should get similar results on the Hoops side. And so it helped make sure that what we were doing could be predictable, especially as we wanted to keep up to date on the Hoops Visualize releases. This helped give us some sense of that it's behaving the same way that we would expect. So one of the other insights is around shell coloring and how we're rendering this geometry. And so we needed to have different results, different temperature results rendered on shell geometry that might be different on the front and back, and also maybe different at each vertex. And so this was a core feature that we needed to bring over from the legacy engine. And the main feature that we used in Hoops to accomplish this was to render using textures. And so here, we're not using textures in the previous sense that you might think like, a rock texture or anything like that. This is a texture that has this gradient, and it allows us to render these results on these elements, and then it's different on the front and back, which is one of the features that textures allowed provides. And another one is certain custom rendering effects. So because we had a homegrown engine that we could go down and tweak as we wanted, there were certain features that may be custom to our product that may not be universal across all CAE products. And so this kind of forced us to map what we had as a feature to some capability within Hoops. And so that mapping process, happened throughout this entire conversion. And so, one of the custom things that we did was this inside-out rendering, where we needed to see the inside of an exhaust system, but still see the context for where this pipe is. But you needed to be able to see the internal temperatures, because that's where the max temperature is. And so by doing this inside-out rendering, it accomplished that. And this was one feature request that we made of Hoops to do this full front-face culling. And that was maybe one missing feature that Hoops had that we were able to then now take advantage of to do this custom rendering effect. So I think that was the last insight that I had. So I don't know if there are any questions.
There is. Well, first of all, thank you, James. I know that was quite a journey for you. One question: what was your approach for switching the immediate rendering to retained rendering and using the scene graph in Hoops? How did you approach it to support switching between legacy and Hoops rendering, as those are very different? What a good question.
Yeah, that's a good question. So previously we had started using OpenGL2, which forced us to kind of retain some of that data ourselves. So we were managing our own buffers and things like that. And so in one sense, we were, at least at the lowest level, we were kind of trying to retain as much of that as possible. But it was a large switch. So especially going from shaders and some of the management of the buffers, a lot of it was made easier by using some of the shell kit and things like that. But it also forced us to identify, like I said, with those features, to identify, like one of the very first ones was be able to draw a triangle, right? That's something you'd never really think about. Once it's done, it's done. But having to force yourself to go back and figure out, okay, how are we going to get this data into Hoops, and then build on that, adding more and more functionality was kind of our approach.
Yeah, great. And I know there are some interested in doing, following a similar path to you. It sounds like you got an improvement in performance. That was one of the reasons, the catalysts for making the switch. Can you give just some ballparks around the effort? How long did it take, the number of engineers that have been kind of working on this project, and if they've been able to get reassigned? That's one of the benefits of using a bespoke graphics engine is you can now focus on not just graphics, but your core expertise, and that's analytics.
Yeah, that was one of the main motivations, is that, if we have these engineers, and we say our focus is on a thermal product, let's focus our engineers on that side of things. But it was a long process for us, at least. There were like 3 to 4 developers and plus a tester. And part of, maybe one reason it did seem to take a while, only because we seem to have, because we couldn't break things, because the users had certain expectations, getting the tool to give us the exact results that we needed. I think that was the most time consuming part. So if we were flexible and it was a brand new product, I think getting something up and running would be drastically different. But because we had these features that we were needed to match, that's where a lot of the effort came in. So it was a long kind of process in that sense.
Yeah. And then how about a last question? Can you give an idea of the level of graphical abstractions that you developed during your refactoring stage?
Yeah, so we had a few. So that's a good question, because from the application point of view, there are 2 main ones where the application looks at this window as just a window that can get resized and shows something. And then the other abstraction was around a scene. Like if you have a model, what kind of operations are you doing on a model that are abstract? Like something changed, or you changed our display setting, things like that. So those are the 2 main ones. But also we used a kind of aggregation of abstractions where, in our models, we're really part focused. So there's a lot of parts that kind of collect elements together, and those parts all have common attributes. And so by aggregating certain attributes, like, is this selectable, or is it renderable, or is it, does it interact with certain kind of results exports? So aggregating those kinds of abstractions also was really helpful.